All right. So I'm moving this up to the other screen. I was just asking people if they like it on this screen or the top screen. It's easier to have it up here so we can have the textbook open here a little bit bigger, but I will always try to have the assignment there. Today we're in 333, so I would label your notes, please. Your homework is 9 questions, but just to look at it really quickly, the questions are not super deep. It is all about arithmetic properties. So we've got some practice of identifying are the steps right. We've got some practice making sure we follow the order of operations. And you've got the answers posted online. So this is really good test preparation. Okay? If you want to do well on the mastery, take this homework seriously. Remember, the magic diamond has the product at the top, sum at the bottom. So we'll try to get to some of these problems. If we can get through the lesson quickly today, and we may skip some problems as we go, we will try to get to doing some of your homework so that you have less to do. Yeah?
When is the mastery?
Don't know. Not this week. Yeah, not. Well, we might. So I was trying to do a mini mastery last week, and we did not do it. Well, we might do a mastery. We might start it on Friday. It will not be due this week. So that's the big thing with like when I give tests. And like Mrs. Pettigrew with her masteries will sometimes just hand you the questions like a week ahead of time. Like, here's what the test will be. Make sure you know it. I kind of operate the same way, except I know there's different apps and things that you can get problem solved for you. So I need you working in class, so I can't let you take the things out of class. But I like to split my assessments up. So you have, here's day 1, do what you're able to do, see what you can't do, and go learn what you can't do. Ask for help. Revisit the videos, revisit your textbook, whatever, then come back to it. So we'll probably maybe start the Mastery Friday, but we would continue it on another day next week, further down. So we all know our operations, right? Our order of operations. What is that mnemonic device, that word that's not really a word, that we remember for order of operations?
PEMDAS.
PEMDAS, right? Now, the danger is people are used to writing it like that, and that's totally wrong.
Wait, what?
Totally, absolutely wrong. The only correct way to write PEMDAS, I need you to put in your notes right now, please. And actually, I'm going to switch screens because I don't like writing with the textbook. We are going to start with the P at the top and build a ladder for the order of operations. So if you're taking good notes, we have our date. Today is 11/8. You should know because it should already be written down in your notes. We're in 333. Our order of operations must be written vertically like that. Why? Who can tell me why that's the right way to write it as opposed to just string out? Liam? Like opposites that are the same, so we kind of say they're inverse operations. Patrick? Exponents. Yeah, we haven't done much with that yet. So do I do multiply before I divide? Please make a note here. These are always same time, left to right. It's not that multiply happens before division. And I will apologize to you for your previous math teachers that made you think that. Like we've said, we've been teaching some things a little off, and you come from 11 different schools. But we don't multiply then divide. We multiply and divide at the same time, reading like a book, left to right. Same thing for addition and subtraction. So you can make little tick marks because that means exactly what's above it. Those are ditto marks. We always multiply and divide at the same time, working left to right. Same thing when we step down and then add, subtract. But there's multiplication or addition or division or any of that in parentheses, that's gonna make it happen first. So anything in parentheses has to happen first. So dive into 112 and look at helping Juno with this problem. So talk as a team, figure out your answers. I'll give you a few minutes on this. Talk with your team. We're really quiet, and I don't know why. I've never had such a hard time to get people to talk. And I know it's early. Maybe I should have a coffee bar. Maybe like, okay, I'm joking. I would never give 7th graders coffee. I didn't drink coffee till I was 22. Senior year in high school, or senior year in college. Senior in high school. Talk. What do you think? Is it 30? Juno thinks it's 30. If it's 30, is how he got there correct? If we have time at the end of class, somebody remind me to show you something on Schoology. People are getting confused. If we have time at the end of class, remind me to show you something on Schoology. We'll go minimum. Penelope. Everybody's here today. I thought I was safe. All right, going back into I know. Allie, did your group think that Juno was correct, that this is 30, or did you think they were incorrect? Okay, how did we get there?
Well, you add all the positives and then take
Okay, what do we get when we add, so I make positives, I'm going to use purple here. So these positive values, right? So 24 plus 3 makes 27. 27 and 7 will make 34. Then a negative 4. Anyway, I get 30, but that's not at all how Juno did it. Juno said he had 20 and 10.
Oh, I know what he did.
No. I love those moments. Those are the light bulb moments. That's what we call that in teaching. So wait. So Allie, you got 30, but you didn't follow. Well, or Juno didn't follow you. Do you know why?
Because you took the -4 away from the 24 and added the 3 and 7.
So Juno did these and these. Was he allowed to do that? Is Allie right? Is Juno right? Who's got thoughts? A lot of hands were up. I swear there were a lot of hands up. Grant?
Everybody wins.
Everybody wins? How does everybody win?
Because there's multiple ways to Florida.
What do you mean? Do we know the mathematical property? You're absolutely right, but do we know how we say this? What rule in mathematics? Hint. vocab words tend to show up in blue on the digital textbook?
Commutative property?
It's the commutative property. Now, hold on. We're going to be more efficient. We are going to write that multiplication, even though we didn't just multiply, multiplication and addition are commutative. I'm going to be as efficient as I can with you guys. I promised you. Trying to make your life easier, not harder. What's the root of that word? Commutative. We talked about this just mildly. Pardon? Yeah, together. So that's the very, very root. But if we look at a bigger root than that, commute, right? That means, well, really the property together, the whole word together, means order, can, move, or change. So we can change the order. So commute means to move, right? When you commute to school, you move to school. You commute to work. Nathan, you're writing this down, bud? When you commute, you move. So we can move our numbers. What Juno did, and actually Allie did this too without realizing it, Juno took 24 plus -4 plus 3 plus 7. Is it still the same numbers? Will we still get the same answer? Yeah, because addition and multiplication are allowed to change order. Questions? That's as efficient as we can write that in. If you're on the digital textbook, click on that, pops up with the definition. So always can use that if you're having any issues. Look at 113 with your team, please. Or sorry, we just really talked about that. Never mind. Look at 114. Like I said, we're going to try to be quick with this. Actually, I can't breeze over this that fast. There's one more thing we want to write down. Let me see if I have space at the bottom or not. Yeah, a little bit of space. Because we just wrote commutative, and if you're a person that uses a highlighter, I would highlight that. The other property we want to write down is associative. And it's up there in blue also. Yeah, I'll use purple, so it's a little bit different in color. What does it mean to associate? What does it mean to associate? If you say, I associate with this group, or I don't associate with that group. Aubrey? Okay, yeah. Yeah, work with.
Not be involved with.
Yeah, who you're involved with, who you work with, who you talk with, who you do math with. So the associative property we apply when we use parentheses to group things. So if up here, after I apply the commutative property, then apply the associative, that would group this addition and group this addition. Please show that in your notes, and I'll show you why in a moment, but please go ahead and put those parentheses in. Those parentheses are showing us something that I hope you are mature enough for me to tell you, because you will never forget it ever again. Give me your eyes, because there's a couple things I can't say. Now, I am smarter than to ask this, but when I asked what the root of the word commutative was, we got down to commute. And we got there from com, like together, go together. If we break down the very roots, and first year teaching, I asked this, and it was very funny. Look at the first 3 letters of the associative property. Right, that's a bad word. Right? No place in school for that word. But if we think about those first three letters, don't parentheses kind of look like butt cheeks? I mean, if we're honest here. I mean, come on, they kind of look like, come on, you all thought it. I just said it. You just won't admit it. Okay, I'm joking, right? At some point, I thought this up. So, when we are talking about the associative property, you have to involve those butt cheeks. You got to involve those parentheses. I am an anomaly. But I bet you're going to remember this now. Now, commutative, hold up. Commutative does not need to involve those. It does not need to involve the parentheses. We just change order. We just move. Associative, you're in Accelerate 7. Do you remember the associative property based off the fact that I told you it looks like a butt?
Oh, yeah.
All right, what's up? What do you...
Mrs. Goldring, we have a math problem that we can't figure out, so we need to...
All right, look at 114. So check that one out. We're going to look at, does commutative property hold true? Does associative property hold true? Please write in your notes just a little something really quickly. Like you could even just say grouping. The associative property comes down to grouping. Who are you grouped with? So check out 114 with your team. Let me go help Goldring's class. Yeah, you could always grab some.
What?
Oh my god.
Huh? What? Oh. Oh. Yeah. Did you hear that?
Yeah, we're gonna have a cheat sheet right here. Yeah. Oh, for that.
His hair is bald.
Wait,
what?
114.
Two plus four.
Mr. Smith may disagree with how I teach the associative property. Who knows? But it has worked in the past. So. Uh-oh.
Not really, but I also did not ignore that. The obvious connection there.
Right? Like, we all know it. So you guys are looking at 7 minus 2 plus 4 and trying to figure out, does order matter? Does grouping matter? I don't want to crayon.
That looks like grass.
It's the crayon setting. So it then asks, okay, what happens? Is it the same if I do 7 minus 2 plus 4? What about if I do 7 minus 2 plus 4? What property has been applied here? The associative. I grouped. Question is, are they the same? Are they right? So how should this be solved?
Left to right.
Left to right, because it's all addition subtraction. What's 7 minus 2? What's 5 plus 4? So we get 9. All right, let's solve the grouped. Well, what's 7 minus 2? Plus 4. Sweet. 7 minus, well, we got to solve 2 plus 4 now. What's 2 plus 4?
6.
What's 7 minus 6? Wait a minute.
Huh. Whoa.
That's how we say not equal. True mathematical symbol, equal to slash. Why? Why did this happen? What can't we do? So we said we applied the associative property, but it looks like we broke something, right? This is a no-no, right? We can't do that. We broke it. We got the wrong answer. Why did we get the wrong answer? The parentheses were on the back table. So what did that do? It made me work that addition on the right side before I worked the addition on the left side. So I wonder, is associative property really a good thing for addition and subtraction? Because that just broke this one. Did you guys play with the problems in part D? What about C? Did you get there? So what about order, right? The order of numbers. We know that 7 minus 2 plus 4, we said that's 9. What about 2 minus 7 plus 4, they say? So I switched some order around. I'm just applying the commutative, right? 2 minus 7 plus 4. What's 2 minus 7? Negative 5 plus 4? Wait. I got a third different answer. Try part D. Play with that for a minute. Alan, do you have any ideas like how we just broke stuff or why it got broken? I'm just drawing cards, so if you haven't figured anything out, like I'm just curious if anybody has any hypotheses. Why did this get broken? What about Penelope? You're back now. Do you have any ideas why this got broken? Okay, we used parentheses. But also, when we changed the order, we got a different answer too, right? So here, adding the parentheses was fine. I got the same thing. I put parentheses somewhere else, got something different. Changed the order, got something different. So again, think about the difference between if I put parentheses here versus if I put those parentheses here. It will change our answer, right? Anybody have an idea why it got broken or what we did that we're not allowed to do? All right, let's solve these really quickly. Nathan, in the first one here, what do I do first? Yep, so 10 minus 2 is 8. Then we get perfect. And the next one, Aubrey, what do I do first? Yeah, so what's 3 minus 5? Negative 2. So then, yeah, then minus 2 more makes negative 4. We get to positive 2. Please make sure you got these right answers. If you did not, your order was probably slightly off. Emily, what about my third one here? What do I do first there? And what do we get? And then we get. What if I change the order of these problems? Will they get the same answer? Why? We said we can change the order for some problems. What's wrong with these? They are subtraction. So wait, I thought addition and subtraction were the same thing, though. Polar opposite. Is there a way? So wait. I can apply this rule. I can apply this rule to addition, but I can't to subtraction. Is there a way to make those problems able to use those rules? Is there a way to make it all addition? Talk with your team for a minute. Is there a way to get those problems to be just addition?
We have an idea.
Try it out. You have to show that you'll get the same answer. If you have an idea, you have to show you'll get the same answer. Marvin, you said your group's got an idea. Do you guys want to share it?
Yeah.
What is your idea?
So for instance, for 10 minus 2, we just do 10 plus negative 2.
Ah, so they're saying instead of using this as subtraction, we can also use it as a negative. Okay, and then I can still keep this plus 4. So what if I now write this as 10 plus 4 plus negative 2? Will that get me 12?
Yeah.
What if I write, and you guys do not have to write this stuff out, 3 plus negative 5 plus negative 2 plus 6. And then I could change the order, right, to 3 plus 6. What's that? 9 plus the negative 5 plus the negative 2. Well, how much negative do we have? Negative 5 and negative 2. 7 negatives. 9 plus 7 negatives. Well, that gets me 2. So, if you're following your textbook, Juno in 115 says exactly what Grant's group just said. Instead of subtraction, add a negative. Try that with A and B here, the 17 minus 4 minus 11. Rewrite those as addition of negatives. And in this case, it will be easier if you work right below it. It will make more sense for your brain if you write it right below it. Anybody confident enough to want to write it out? Yep. You want to write it up? You can rock, paper, scissors for it, or one of you can take A and one of you can take B. If you want to come up, just come up now. We gotta hurry. We only got like 10 minutes left. So write it right below, yeah, right here. You're on red. Is what you're gonna do. Are those parentheses applying the commutative property? Grant, keep writing. Are those parentheses that he's writing applying the, sorry, are they applying the associative property? Not those. Are those parentheses grouping numbers together? It's only grouping a number. When it's not, like, you can't yourself be a group, right? I can't be like, I'm the bike club. No, I'm just a guy that rides my bike. You need multiple things to group. So that is not applying the associative. That's just grouping a negative by it, like, as itself. He actually doesn't have to have those parentheses there. It just cleans it up. And I would advise always having it. But that is not the associative property. That is perfect. What do you get for the blue one or the red one, since we'll get the same answer? Anybody got solved? Liam? 7 to why? You want to talk it out, Grant? Because we could apply the associative property to make this really easy. What if we put parentheses around the negatives and do that first? What's a negative 4 and a negative 11? 15 negatives. What do we call a number and its opposite? Additive inverses. Get that in your head, guys. That's really important. Number and its opposite, additive inverses. So that's how great that's. Thank you very much, Mr. Curry. You are an expert. Maybe someday you'll be a college professor. Something like that. Professing great knowledge. Now B's harder. Because it's got multiplication. What? Did it? Ah. You are correct. So this negative is already grouped by himself, like as the negative. For sake of time, we're just going to run through these. You should have here 2 plus group negative 2 times 3 plus negative 4 plus negative 2 times negative 4. Now these multiplication dots are not necessary, but I do things that aren't necessary so that my brain doesn't have to work any harder. Then we could apply the associative property if we want to make this even cleaner, even nicer. What could I associate together? Patrick?
2 plus 2 to the
Yeah, solving this first would be nice. And we're going to do that first anyways because it's multiplication. But also solving this first would be nice because that's also multiplication. What's this parenthesis going to become? Negative 2 times negative 4. William?
Don't the negative cancel each other out so it's positive?
Becomes positive. So in here is 8. Positive 8. I'd be writing the solution down, please. This is pretty much what your homework is, solving these. So now we have 2 plus, what's this parentheses? Negative 2 times 3?
Negative 6.
Negative 6. We got a negative 4. And then a positive 8. Again, we can apply our associative property if we want. Or we can apply commutative. Commutative would say, hey, positive, come out here and add with me first. Negatives, you can do your thing over here. What do your positives add up to? What do your negatives add up to? Yeah, negative 10. So what do we get?
0.
Big fat goose egg. 0. What do we call a number and its opposite? Additive inverses. Questions? I still got 8 minutes, so don't think that we are hungry. Oh, 5 minutes.
Favorite color?
Changes. Probably green. Considering I decided to have that tattooed on me. But, oh, people are like, wait, is he for real? Yeah, the word green, but it's written in purple. No, that's a lie. Have you ever seen those like brain things? Now the question is, who in here now believes that I actually have a tattoo? That's what's like going through your head now, right? Maria and George, spelled in a really sweet way, are looking at this problem. I hate how that came out with the Zoom. I don't like how it broke up that problem. I'm gonna zoom in, zoom out, maybe I don't know.
Yeah, it's Jorge.
Okay, good.
Thank you. I'm glad that people caught it. So, Maria started by rewriting. I really don't like how the Zoom is happening, guys. I'm sorry. I can't really get this to fix. All right, I'm going to leave it like this and hope that maybe this screen makes it better. Pay attention that this is part of that negative 3/4. So really just come down here. So Maria has this work. Investigate her work. Did she make any errors, or is what she's done okay? So investigate this for a minute. Like you're checking your friend's work. How did she get negative 21 over 20? Where did that just go? How did she get negative 21 over 20? Allie? So, this makes her 21, and she took the negative, and well, the negative's now up front, but she just takes it with her, and this gets the 20. Now, technically, is that what she should have done first? No, but since this is all multiplication, can I change the order in which I do things? Yeah. What rule is that? Starts with a C. Commutative property. Now, she didn't physically show it. She didn't actually move things. We would want to actually move things, but that's what she's thinking about. Very nice. Allie said, here's how that 21 and that 20 happen. One of them is negative. It stays negative. Okay, sweet. So then try numerator times numerator. Does it get 84? Denominator times denominator. Does it get 60? Does that check out? Yeah? No? Anybody? Are we good? What's a negative times a negative? Positive. Does this 84 over 60 check out? Yeah. And then the rest of the work does too. All right, so Maria looks okay. She kind of skipped a step in there. But Jorge has a different idea. He says, so wait, what if I multiply these first, and then, so I'm going to capture this real quick. And then finished yet. Try this. He first wants to multiply these. What would then have to happen? So try multiplying this first. Go ahead and jot this down on your paper. Try multiplying that first, right? Those are two parts of the problem that we had, the -4/3 and the -3/4. Those are two parts we had. All he did was change the order. He's applying the commutative. Why is the question? Yeah, I ran out of pages. What do we get when we do Jorge's -4/3 times -3/4? Monica? 12 over 12. Alex, what's 12 over 12? 1. Jorge saw multiplicative inverses. An inverse flips a, well, okay, so I lied. Not multiplicative inverses, but reciprocals. Reciprocals just flip. And since they're both negative, negative times negative, positive, we would then end up, well, with the other term is going to be my answer, right? That other number. Please try your homework. We will take homework questions tomorrow. That's primary focus. Homework questions tomorrow. Have a great day. I'm digging your penguin. That's a great sweater. I was a penguin for Halloween.